So for me, there's a couple of different ways that I can think about working numbers 5 and 6 on the homework. But I typically use my two special right triangles every time I get a chance. And on both of these problems, you can work them using our special right triangles. So we have let's say this is a 45, 45, 90 special right triangle. For this triangle, both the legs are length radical 2 and the hypotenuse is 2. And then for a 30, 60, 90 special right triangle, the side opposite the 30, or the short leg, has a distance or a length of 1. The side opposite the 60 is a radical 3, and the hypotenuse is a 2. Hopefully you've seen these before, and so I'm going to teach them doing this way, and if that's good with you, then we'll take it that way. At the very end, I may mention how you could do it if you didn't know your special right triangles, but that's the way I'm going to be explaining both problems. So for the first one, it tells me I have a point that's at 5, negative 5 radical 3, and it wants me to give the ratio of the 6 trig functions. So in a coordinate plane, if I need to go to the point 5, negative 5 radical 3, that means I'm going to be going to the right 5, and I'm going to be going down negative 5 radical 3. So if I draw a line from the center to that point, like so, and then I drop a perpendicular foot here to make a right triangle, I know that I went to the right 5, so this leg has a distance of 5. I went down negative 5 radical 3, so this leg has a distance of 5 radical 3. And so to me, I can see, just from the ratios alone, that this is some version of a 30, 60, 90 special right triangle. Because here, this side length, if I divide by 5, is 1. This side length, if I divide by 5, is radical 3. So I know this side length is supposed to be 2. So if I divided this number by 5, I would get 2, which means my hypotenuse is a length of 10. Now, because I am in the fourth quadrant, only cosine and its reciprocal are positive. Only cosine and its reciprocal are positive, so I have to keep that in mind as I'm working this out. So here's my central angle. So this is the alpha that we're looking for. So if I needed to find sine of alpha, sine is going to be negative, and it is the opposite over the hypotenuse, which would be 5 radical 3 over 10, which reduces to just be what I would get if I had my original 30, 60, 90. So it reduces to be radical 3 over 2. So sine of alpha is negative radical 3 over 2. Cosine is going to be positive, and it's going to be the adjacent side over the hypotenuse. So that's 5 over 10, or a half. Tangent of alpha is going to be negative, again because I'm in the fourth quadrant. And tangent is the opposite over the adjacent. Sorry about that. The opposite over the adjacent. So that would be 5 radical 3 over 5, which is just radical 3 over 1, which we can write as radical 3. So for me, those are the only ones that I would find, would be these 3. And then the other 3 are just the reciprocal. The other 3 trig functions are the reciprocal of my big three, or these original three. So the reciprocal of sine is cosecant. So cosecant of alpha would be negative 2 over radical 3, right, if I just flip it. But we're not allowed to have a radical in the denominator, so I'm going to multiply by radical 3 on top and bottom. So that would give negative 2 radical 3 over 3. That would be for cosecant of alpha. Sorry, I'm kind of running out of room here. So I'm going to go up here, clear space. Next, I'm doing the reciprocal of cosine, which is secant. So if I was finding secant of alpha.
Good morning, teachers.
That would give me, the reciprocal of cosine is secant, so that's 1 over 2, so this would give 2 over 1, which reduces to be 2. And then I need to find cotangent of alpha. That's going to be the reciprocal of tangent of alpha, so that's going to be negative 1 over radical 3. And again, I need to rationalize this, so I'm going to multiply by radical 3 on top and bottom. And so that is going to be negative radical 3 over 3. Okay, so here I'm told that the shorter leg is 1 unit long. So I'm going to put that on the drawing here. So across from beta is 1. It tells me the longer leg is 2 units long. So the first thing I need to do is find the missing side, which is the hypotenuse. I can find that missing side by using the Pythagorean theorem. So one leg squared plus the other leg squared equals the hypotenuse squared. This would be 1 plus 4 is c squared, so 5 is c squared. When I take a square root of that, I'm going to get c is equal to the square root of 5. So I know that my hypotenuse there is radical 5. Now it asks me first to find sine from the angle alpha. So I'm going to go to alpha, which is this angle right here. Sine is the opposite leg, which is 2, over the hypotenuse, which is the square root of 5. But I'm not allowed to have a radical in the denominator, so I'm going to multiply by radical 5 on top and bottom. That's going to give me 2 radical 5 over 5 for sine. You can continue this for all the other trig functions. Like I said, the one key here is sometimes it's going to ask you to do it from the angle alpha, and other times it's going to ask you to do it from the angle beta. So if I was asked to find sine from beta, that would be the opposite of 1 over the hypotenuse of radical 5. But it's still the same process for rationalizing the denominator.